Download this code from codegive.com, link in the description below. OK, let's dive into a detailed tutorial on reliability using the C programming language, covering concepts, common problems, and techniques, along with code examples. We'll aim for a level that's beneficial for both beginners and those with some C experience who want to write more robust and dependable programs. We'll also cover best practices. Tutorial: Writing reliable C code. Introduction. Reliability in software engineering refers to the ability of a system or component to perform its intended function consistently over a specified period, under defined conditions. In C programming, achieving reliability requires careful attention to detail, rigorous testing, and a deep understanding of potential pitfalls. Unlike some higher-level languages with built-in garbage collection and exception handling, C places a greater responsibility on the programmer to manage resources and handle errors explicitly. Key aspects of reliable C programming. 1. Memory management ***. Understanding dynamic memory allocation **. C relies heavily on functions like malloc, calloc, realloc, and free, for dynamic memory allocation. Failure to manage memory properly can lead to memory leaks, unused memory that is not released, dangling pointers, pointers that point to deallocated memory, and segmentation faults, accessing memory outside the allocated bounds. Avoiding memory leaks *. Always pair malloc/calloc with free when the allocated memory is no longer needed. Use debugging tools like valgrind on Linux/Mac OS, or address sanitizers to detect memory leaks. Preventing dangling pointers *. After freeing memory, set the corresponding pointer to null. This prevents accidental dereferencing of the freed memory. Buffer overflows *. Carefully check array bounds when accessing memory. Use functions like strncpy and tinprintf instead of strcpy and sprintf to limit the number of bytes written. Double free *. Avoid calling free on the same memory location multiple times, as it can corrupt the heap and cause crashes. 2. Error handling **. Checking return values *. Many C functions return error codes. Always check these return values to determine if the operation was successful. For example, malloc returns null if memory allocation fails, and file IO functions like foopan and fred can return error codes. Using errno *. The errno global variable stores error codes for certain functions. You need to include errno.h to use it. Use pererror or streerror to print a human-readable error message based on errno. Assertions use assert from assert.h to check for conditions that should always be true. Assertions are typically disabled in production code, but they are valuable for debugging during development. Custom error codes and handling *. Define your own error codes for specific functions and modules. Create functions to handle errors in a consistent way, such as logging error messages or taking corrective actions. Avoid ignoring errors *. Never assume an operation succeeded without checking the return value. This is a common source of bugs. 3. Data validation *. Input validation *. Validate user input or data from external sources to prevent unexpected behavior, such as buffer overflows, format string vulnerabilities, or invalid data types. Range checking *. Ensure that values fall within acceptable ranges. Type checking *. Use the correct data types and consider using static analysis tools to detect type errors. Sanitize input *. Clean user supplied input to remove potentially harmful characters. 4. Resource management *. Asterisk file handles asterisk always close files using fclose, after you are finished with them. Failure to do so can lead to resource leaks and file corruption. Asterisk sockets asterisk close network sockets using close, or shut down, after use. Asterisk mutexes, semaphores, and other synchronization primitives asterisk release resources after acquiring them to prevent deadlocks or other synchronization issues. Use thread underscore mutex underscore lock, /thread underscore mutex underscore unlock, sem underscore wait, /sem underscore post, etc., in a balanced manner. 5. Code structure and design asterisk. Asterisk modularity asterisk break down your code into smaller, well-defined functions and modules. This makes the code easier to understand, test, and maintain. Asterisk abstraction asterisk hide implementation details behind interfaces to reduce dependencies and improve maintainability. Asterisk code reviews asterisk have other developers review your code to catch errors and improve code quality. Asterisk defensive programming asterisk write code that anticipates potential errors and handles them gracefully. Asterisk commenting asterisk write clear and concise comments to explain the purpose of your code. 6. Concurrency and multithreading asterisk. Asterisk race conditions asterisk protect shared data using mutexes, semaphores, or other synchronization mechanisms to prevent race conditions. Asterisk deadlocks asterisk avoid deadlocks by carefully managing resource acquisition and release order. Use techniques like lock ordering or timeout mechanisms. Asterisk thread safety asterisk ensure that your code is thread safe if it will be used in a multi-threaded environment. Use thread local storage for data that should not be shared between threads. 7. Testing asterisk. Asterisk unit tests asterisk write unit tests to verify the correctness of individual functions and modules. Asterisk integration tests asterisk write integration tests to verify that different parts of your system work together correctly. Asterisk regression tests asterisk write regression tests to ensure that bug fixes do not introduce new problems. Asterisk fuzzing asterisk use fuzzing tools to automatically generate test inputs and detect vulnerabilities. Asterisk code coverage analysis asterisk use code coverage tools to measure how much of your code is covered by your tests. Asterisk static analysis asterisk use static analysis tools to identify potential problems in your code without running it. 8. Build process and configuration management asterisk. Asterisk version control asterisk use a version control system like Git to track changes to your code and collaborate with others. Asterisk build automation asterisk use build automation tools like Make, CMake, or Auto tools to automate the build process and ensure that your code can be built consistently across different environments. Asterisk configuration management asterisk use configuration management tools to manage the configuration of your software in different environments. Code examples. Here are some C code examples demonstrating various reliability techniques. Explanation of examples asterisk. Asterisk safe underscore string underscore copy, asterisk demonstrates allocating memory with malloc, checking for allocation failure, copying the string using strncpy, to prevent buffer overflows, and ensuring null termination. Free underscore string, ensures the memory is freed and the pointer is set to null to prevent dangling pointers. Asterisk safe underscore fpin, asterisk demonstrates opening a file and checking for errors using fpin, and per. Asterisk safe underscore atoy, asterisk demonstrates converting a string to an integer safely using strtl, checking for invalid characters, and handling out of range values. Asterisk divide, asterisk shows the use of assert to enforce a precondition. Asterisk process underscore file, asterisk illustrates proper file handling, including opening, processing, and closing the file while checking for errors at each stage. Best practices. Asterisk code style asterisk follow a consistent code style, example indentation, naming conventions, to make your code more readable and maintainable. Asterisk linting asterisk use linting tools to automatically detect potential problems in your code, such as unused variables, code style violations, or potential security vulnerabilities. Examples include check and clang tidy. Asterisk static analysis asterisk use static analysis tools to identify potential bugs without running the code. Examples include Coverighty, Fortify, and Clang Static Analyzer. Asterisk dynamic analysis asterisk use dynamic analysis tools, debuggers, memory profilers, to analyze your code's behavior at runtime and identify performance bottlenecks or memory leaks. Asterisk documentation asterisk write clear and concise documentation to explain the purpose of your code and how to use it. Tools like Doxygen can generate documentation from comments in your code. Asterisk continuous integration / continuous delivery, CI/CD automate the build, testing, and deployment process to ensure that your code is always in a consistent and working state. Advanced topics. Asterisk memory pools asterisk implement memory pools to improve the performance of memory allocation and deal location. A memory pool pre-allocates a large chunk of memory and then divides it into smaller, fixed-size blocks. This can be useful for frequently allocating and deallocating small objects. Asterisk object pools asterisk similar to memory pools, but for objects. Pre-allocate a pool of objects and reuse them instead of creating and destroying them frequently. Asterisk RAII, resource acquisition is initialization. While C doesn't have built-in RAII like C++, you can emulate it by encapsulating resource acquisition and release within a structure and using constructor/destructor-like functions. Asterisk finite state machines, FSMs use FSMs to model complex systems with different states and transitions. FSMs can help you write more robust and predictable code. Asterisk watchdog timers asterisk use watchdog timers to detect and recover from system failures. A watchdog timer is a hardware or software timer that resets the system if it is not periodically reset by the application code. Conclusion. Writing reliable C code is a challenging but rewarding task. By following the techniques and best practices outlined in this tutorial, you can significantly improve the quality and dependability of your C programs. Remember to prioritize memory management, error handling, input validation, resource management, and thorough testing. Embrace static and dynamic analysis tools to catch errors early in the development process.